Let's now look at the concept of a recurrent network. In a recurrent network, we would have the input. So let's say this is the input we have, and this input is, let's shade this area. And as we have seen in the uh, previous architectures of neural networks, let's say the shape of this neural network is R, and if we draw an arrow from here, this would be our uh, input vector. So this is the column matrix. This would be of shape R by 1, and this would be input to, previously we said that this would go directly to a W, where we multiplied W by P. But in the recurrent case, that's not what we are trying to do. We do have the box where we have the W right here, but then this value, it doesn't go directly W. That value goes to the delay block first. So the raw input that we have would go to the delay block first, and like so, and then the output of this delay block would be sent back to the weight matrix right here. And so that's how this would work. And we do have the bias. So we have the box here for the bias, which, let's say, we have a value of 1. Now, depending on the number of neurons, let's say there are S number of neurons, the shape of this would be S by R, and the shape of this would be S by 1. And as before, the rest of it is the same. The values from the W and the values from bias would be aggregated here. Remember the equation WP plus B, that's what we are trying to do in this plus. This will then output the net input at particular time. Now let's leave the time out of it right now, and we'll just say that this outputs n, which is the net input, to the transfer function that comes after this. So let's say this is the transfer function, and in this case the transfer function is sat lens, which is shown here by this symbol, and the shape of this would be S by 1. Now the output of this would then directly go to the delay block, and this would be the A, which is the output from the transfer function, again the same shape as the N. And then we have the output A, which again is the same shape as the A we had before. Now when we say recurrent layer, this part right here is the recurrent layer. Recurrent layer, and this part right here is the initial condition. Right, so with this, what we are trying to do is, at time t0, this is the input that goes in. So at time t0, what we are trying to do is take the values from P and input it directly to the delay block. So in case of a recurrent neural network with the delay block, here is how this would work. Now at time t is equal to 0, the stored value, so this is the stored value would be a0, because those are the initial conditions. Then at time t is equal to 1, the stored value is a1, that is calculated when the a0 goes back here, multiplies with w, adds the bias, goes to the transform function that creates the uh, a a1. But then although the a1 is calculated now, the output is still not A1. So the output of the delay block in this case would be A0. At time is equal to t is equal to 2, the stored value would be, or the calculated value that is stored would be A2, but then the output would be the previous value, which is A1. Likewise, at time t is equal to 3, the calculated or stored value would be A3, but then the output value would be A2. And so the way we can show that in this particular diagram is as follows. You can say that this is the output at t, uh, and this is the output at t plus 1, and this is at t plus 1, because remember this output was calculated at a previous time step, and what's calculated right now or new is coming in from the left hand side into the box, and that's why these are the new ones. I'll try and explain this again with some symbols. Let's say we start out and this is A0. So A0 is the initial condition that gets stored in here, and then A0 is also available for output right here. So A0 gets sent back to the through the network to get multiplied with W, and then that allows us to get the net input, which is t plus 1, and that allows us to get A1. Now A1 is available, A1 is calculated, but then it is not what A1 is done. So we take the A1 and we store it inside of this block. We do not output A1 yet, so we just store it in this box, and what we output here is just A0. In the next iteration, what we do is we send back the A1 like so, multiply it with W, add it with the bias, and thus we get a new value for n, and this is the n that we have, which is for 2. So this is the iteration after the previous, and thus the a that we get here again is A2. Now this A2 enters the delay block, and as soon as this enters the delay block, uh, we know that it'll get stored in the delay block and it's not going to be output. So this is A2 gets stored in the delay block to be sent back, and the output in this case, in this iteration, would be A1, because that was what was previously stored in the delay block. And in the next iteration again the A2 is sent back to calculate A3, and this previously stored A2 is then available for output. So that's how the recurrent layer works. And if we want to see the equation for this, we can say that the A0 is equal to P, because that's the initial condition, which are the raw values. Then at A t plus 1, uh, where we are calculating the values, this would be the same structure we had, W times P. Here instead of P we are using AT, YAT, because that's what the delay blocks sends back, and the P we use it as A0, and so we are not using the wording P here, we say AT, and then we add the bias to this. Of course, because this is activation or A, it has to go through some transfer function. So let's say the transfer function is saturated linear, so sat lins, and we get this function right here. So that's how the recurrent layer would work. And again here, let's say if we are calculating the values for a1, so if we say the values for a1, those would be equal to we say sat lins, so sat li and s, and this would be w dot a 0 plus b, and then a2 would be sat lins and w a1 plus b. So we are using the previous value, and what this value of a is, so what a gives us is, so each time we get this, what we get is a summarized uh, summarized pattern, if we will, that we are uh, constantly refining and keeping track of as we go through the time. Uh, and so we keep the reference of the previous time step as we move forward in time. So that's how we can think about recurrent layer. And we'll continue this discussion again in detail in future video. I hope you got an idea about how to think about a recurrent layer in this video. If you have any questions, comments, or suggestions, please do let me know in the comment section below. Thank you.